Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Nass. I am with Embedded Computing Design. This week, my guest is Hannes Scheitzwohl, and he is the Senior Vice President and General Manager of the GaN Systems business line at Infineon. How you doing, Hannes?
Very well. Thanks for having me on. How are you?
I'm doing great. Thank you for asking. Um, so we're in an interesting state with respect to GaN right now, mostly due to what TSMC announced recently that they're exiting the GaN market. Um, First of all, is there more to that? And is it accurate? I know that they didn't there hasn't been anything that they've come across publicly, but have you heard the same thing that they're getting out of the GaN market?
Yeah, I can confirm that. So we got informed from TSMC that they will end their GaN program. Of course, there will be some time where they still deliver products so that a transition is easy for the end customers. But indeed, yes, this is what happened. TSMC has decided to stop their GaN program. Indeed,
Okay.
yes.
Were they a supplier for you?
Yeah, so as you might know, we bought the startup GaN Systems around 2 years ago, and they were sourcing from TSMC. So in that way, we also got access to the TSMC foundry capacity and the foundry technology. And so we had both flows. We had the TSMC flow and the in-house Infineon gallium nitride. So we had both technologies to offer indeed. Yes.
So what does that mean for you guys? Do you have to shift everything over to internal?
At the moment, this is how it looks like. Of course, we work with TSMC that we can have a very smooth transitions for our customers, and TSMC is also supporting this very well. So this is great. At the same time, yes, we will rely heavily moving forward on our IDM model, meaning our in-house capacities that we are expanding, and also bringing new technologies with our in-house technologies into the market. Yes.
Is there a timeline with TSMC when that they will get out?
So this we are working out still the details. So that's too early that I give you here a communication. We are working this also with customers. So we try to understand what they need, and then we discuss it again with TSMC. But we will have a smooth transition. I'm confident on that point.
So I'll speculate, and I know you don't want to speculate, but I'll do it for you.
Right.
This has the potential to be really good for Infineon because you have the ability to take this in-house where other people don't. So could this be really good for Infineon?
I would say we do everything to make it good for Infineon, indeed, right? Exactly as you said, we have our in-house capacities and our in-house manufacturing. We actually also transition to 300 millimeter in-house manufacturing. So this shift of volume will actually help us to go faster even towards this 300 millimeter because we go there as we want to move it to economy of scale. So therefore, from that perspective, it's a good thing. Yes, we have our own supply, we have control over our own supply chain, so that will move more capacity in-house indeed. Of course, at the same time, the challenge is the customers need to also transition, right? So that is also the challenge that comes with it.
Does Infineon produce this internally at one location or is it at various places around the world?
Yeah, so we always, as Infineon in all technologies, try to have multiple locations, also for supply chain security. So we do GaN in Austria, in a town called Villach, and then we also now start to ramp in Kulim, Malaysia. So we have two independent fabs where we do gallium nitride. Yes, indeed. So we have two in-house fabs where we manufacture gallium nitride at Infineon.
Would you potentially look to be a partner for some of the other folks who had been working with TSMC who are now looking for a manufacturing partner?
Yeah, we do offer bare die business, indeed. We do this in other areas of Infineon. We do it, for example, for silicon since even decades. So we have this business model also. And yes, we're open for that to also offer this Infineon technologies to other suppliers. Yes.
So does that mean you'd be manufacturing for your competitors?
That might happen. As said, so we have this business model also in other areas of Infineon where we provide silicon devices to other suppliers, also to our competitors, but we have a very good policy inside of Infineon where we have firewalls, where we separate this bare die foundry business from our own power business. So it's workable and it's not unique for Infineon, right? There's more industries that do that, so it's totally manageable, I would say.
Okay. So let's shift gears a little bit. We have been talking about a very bright future for GaN for a long time. Are we still talking about the future, or are we talking about the present now? Are you guys making? What's the right way to say this? So I'll just say it. You're making a lot of money today in GaN, and you expect that to continue?
A lot is always relative, but I would say yes, we are making money with gallium nitride, and we expect to make a lot more money with gallium nitride as we move forward. I cannot talk about now the revenue numbers. This I'm not able to do, but what I can say is that the market itself, right? There's market research out there that over the next 5 years we will reach a market of 2.5 billion for gallium nitride. Today it's around 400, 500 million. So you see, it's a massive growth that is ahead of us, and we definitely see this growth coming in a wide range of applications.
Is that US dollars that you're talking about?
Yes, this was US dollars, 2.5 billion US dollars in 2030.
Is it still the EV charging market that you're waiting to take off?
I would say we don't have to wait. There's markets already taking off, right? So what's very well established is in the consumer space, the charge adapter market. So this has transitioned largely to gallium nitride devices. But we also see that in consumer home appliances are now coming in. So there is, from hair dryers to washing machines, increasingly more gallium nitride being used. So this is coming. The second, or the next bigger wave will be AI servers, right? So as certain architectures move to 800 volt DC, we do see gallium nitride being used there. 800 volt DC architecture needs GaN for the 800 volt to 54 volt conversion, and then from the 54 volt down to 12 volt conversion, there's high voltage and medium voltage GaN there. And I don't have to explain how much volume AI is driving. So that's the next big wave. And eventually, yes, there's also automotive there. We have many engagements with customers on onboard chargers, high voltage DC-DC, that want to leverage the benefits of GaN in power density and efficiency.
Is there one thing that's going to take this from the 400 or 500 million that you talked about to the 2.5 billion? Is it the consumer side? Is it the AI, or is it just everything altogether? That's
a very good question. So here, GaN is different than silicon carbide, right? Silicon carbide had this magic moment where Tesla was starting to use SiC in the traction inverter, and then it really jumped up in revenue. GaN is different to the point that really multiple applications start to ramp simultaneously, and that really drives then the revenue. As I said, it's home appliances, it's AI server systems, it's also renewables that is coming now, microinverters, for example, and eventually then also the automotive market. But with all of that, we believe there could be similar growth rates as we saw with silicon carbide eventually.
Explain to me why AI servers will benefit from GaN. We've been making servers for many years without GaN. Why GaN?
Power demand is much higher, right? So with AI, the power demand in a single rack is really exploding. When in the past we talked about 20, 30 kilowatt, now we talk about the target to get 1 megawatt in a single server rack for AI. Unbelievably challenging. And how to do that? Make your power conversion stages as small as possible, so highest power density is important, and practically no power loss, because how do you get the heat out of such a cramped system, right? And here GaN is perfectly suited to address these challenges. You can increase power density significantly by moving to gallium nitride because it switches faster. So we can increase switching frequency and reduce size of converters. And we can do that without increasing power loss, actually reducing power losses, increasing efficiency, keeping the thermal envelope under control. And this is why GaN is perfectly suited for these AI server systems.
You've touched on the heat aspect of that a little bit. How big of an issue is that? And does GaN solve that, or is it just a somewhat of a fix and it's still a problem?
It helps to reduce the power losses, as said, right? So therefore, the heat that is generated is reduced. Still, to manage the cooling in such an AI server system is one of the major challenges. So therefore, one moves to liquid cooling, for example, major engineering efforts in order to manage such a megawatt in a single server rack. But
Okay.
there I would want to say that from Infineon perspective, we really work here with customers on this entire architecture, right? So from grid in down to the GPU or CPU, we have the power conversion architectures and products and system solutions so that we can re-engineer the entire power flow in a way that really we optimize the power delivery, we reduce the losses, and we maximize efficiency, and so that thermals and temperatures stay under control.
Okay. Is there still a lot of room for the performance of GaN to get better?
Oh, yes. So this is, we all know the S-curve, right? So we are still in an early phase of GaN. So we will still see rapid technology improvements, rapid performance improvements. You will see that the next generation of GaN products that Infineon will bring out have a 50% improvement at least of the performance critical figure of merits. That's hard to do today with silicon because that's already quite matured, but you will see huge performance improvements with gallium nitride to come in the next years ahead.
When you've been doing this a while, like I have, you learn that everything comes with trade-offs. What's the trade-off here with the GaN systems?
The trade-off is, I think, implementing GaN in a way that you really get the maximum benefit out of it requires full system redesign often, right? It's not just you take out a silicon MOSFET, you put in a GaN power device, and then poof, your efficiency goes up by multiple percentage points. Typically, it doesn't work. So you need to change topology. Changing topology means new gate drivers, new controllers, new software, new magnetics. So a lot of engineering effort. And that is what we are working together with customers, because we can bring in our GaN devices, we can bring in our gate drivers, our controllers, we develop full system solutions. That's a journey that Infineon went on years back, and now this really helps because we can demonstrate how an 800 volt to 54 volt converter needs to look like for an AI system. So we can build such a system and give it to our customers, right? And also the next stage with GaN. But it really requires the ability to re-engineer the entire system. That is the effort or the trade-off, right? It's additional engineering effort that we need to put in.
Would people say that there's a cost delta and that's the trade-off?
I would say in terms of cost delta, you said, right?
Yes.
I would say on the contrary, typically when you do that, when you invest into optimizing the system and you go with GaN, you can reduce your system cost. That is what we're seeing again and again. Maybe it's less cooling where you save there, or that you can use less passive components. So typically, or the topology is a change by using, for example, a GaN bidirectional switch that we just released. You can reduce the number of semiconductor devices, and so overall system cost goes down. Yeah, so typically what we need to look at is system cost. So I would not agree to the statement that the cost is the problem in moving to gallium nitride based systems.
Awesome. This has been very enlightening. Thank you very much, Hannes.
Thank you.
That was Hannes Schossweil, and he is the Senior Vice President and General Manager of the GaN Systems business line for Infineon. And I am Rich Nass with Embedded Computing Design.